In this video, we're going to take a look at section 4.4, which is on factoring expressions of the form x squared plus bx plus c. To factor polynomials of the form x squared plus bx plus c, we will first start by identifying the values of c and b. C is the constant term. It's the term that doesn't have a variable, so whatever that number is. B is the coefficient of the middle term of x to the first power. So we'll identify those two numbers, and I would recommend identifying them in that order. So C first and then B second. The second step will be to find two numbers, which I'm going to call M and N just to give them some names, that multiply to C but add to B. So if I take M times N, if I take those two numbers and multiply them together, it should multiply up to C, which is the constant term. But if I were to add those numbers together, it should add up to B, which is the coefficient of the middle term. Once you have found two numbers that fit that description, those are the two numbers that go into your two factors. So this is a bit of a shortcut here. I want to point that out, that we're kind of taking a shortcut. Once we find those two numbers, we can just get our answer immediately. We'll take x plus the first number times x plus the second number, and that's how this expression will factor. The only thing that enables us to take this shortcut is that a is equal to 1. Right? So notice there's no a here. We have b and we have c, but a is missing because it's equal to 1. Because it's equal to 1, we can use this shortcut. If a is not equal to 1, then this shortcut is not available, and we'll have to find another way to factor, which is what 4.5 is about. All right, so let's take a look at an example. All right, so we have w squared plus 11w plus 24. The first step is to first identify what c is equal to and what b is equal to. So c is equal to 24, it's the constant term. B is equal to 11. It's the coefficient of the middle term. The second step is to find two numbers that multiply to 24 and add to 11. So I'm looking for two numbers, I don't know what they are yet, that when I multiply them together I get 24, but when I add those two numbers together I get 11. And so this might take some thought to figure out, and some of these will be easier than others. And also some students seem to have a knack for this kind of question, and others seem to struggle with it a little bit more. But with practice, everybody can get proficient at it so that you are able to do these problems. All right. So if you're having trouble thinking of two numbers that will do this, you want to start with the first requirement, two numbers that multiply to 24, and let's make a list of numbers that multiply to 24. You could have 1 times 24. You could have 2 times 12, you could have 3 times 8, and you can have 4 times 6. So those are all the numbers, all the pairs of numbers that multiply to 24. And then look at that list to find one that adds up to 8. And so it'll be this set right here, right? 3 times 8 gives me 24. 3 plus 8 happens to add up to 11, which is exactly what I'm looking for. So the two numbers I'm looking for here are 3 and 8. 3 times 8 is 24. 3 plus 8 is 11. And once you find those two numbers, you immediately get to jump right to your answer. It'll be, I put in the directions x plus the first number, but the variable in this problem is w. So we should use w plus the first number, which is 3, times w plus the second number, which is 8. And that's how this will factor. And so that'll be my answer. All right. You can check your answer, if you'd like, by foiling it back out to make sure that it matches back up to the original problem. So let's go ahead and check our answer. At least this time. I don't know that I'll do this on every problem. Sometimes the directions tell you to check your answer, but Math Excel is not going to know if you actually do that or not. But it's a good idea. It's a good idea, especially on the test. So we'll FOIL. So we'll multiply the first two terms together. F, right? That's F in the FOIL. W times W is W squared. We'll multiply the outer terms together. That's the O in FOIL. W times 8 is going to give me 8W. We'll multiply the inner terms together. That's the I in FOIL. It's 3 times W, which is 3W. And then we'll multiply the last terms together. That's the L in FOIL. And that's going to give me 3 times 8. And I'm going to write that, of course that's 24, but I want to write it out as 3 times 8 to point out why we were looking for two numbers that fit this description. Because notice what happens to these two numbers when you FOIL. The two numbers get added together in the middle to give you 11w, to give you the value for b, and they get multiplied together in the last term to give you c, which is 24. So that's why we were looking for two numbers that fit that description. Because whatever two numbers we put in our answer, that's exactly how they're going to behave. They're going to multiply together to give us c, and they're going to add together to give us b. All right, and so this checks out. Gives us the right answer, so which is the problem that we started with. Let's try another one. We have v squared minus 13v plus 40. So things get a little bit more difficult once you start throwing in negative numbers. So let's go ahead and do this the same way. Step 1, we'll identify c, which is positive 40, and b, which is negative 13. So now we're looking for two numbers that multiply to positive 40, but add to negative 13. Again, if you're having trouble thinking of two numbers that do that, it might help you to make a list of numbers that multiply to 40. So you have 1 times 40, and I know that obviously is not anywhere close to 13, but I like to be thorough. So I start with 1. 1 times 40. 2 works because 2 is even, so 2 times 20. Then we'll do 3. Well, 3 doesn't work, right? So let's undo that. 3 doesn't divide into 40, so it's not going to be a factor of 40. 4 works, though. We have 4 times 10, where we're getting close to 13, right? 4 and 10 add up to 14. 5 works because it ends in 0. 5 times 8. And there's nothing else to really find here. There's no more pairs of numbers that multiply to 40, but if there were, we wouldn't have to keep going, because as soon as you find the numbers that work, you should just stop. Right, so 5 and 8 multiply to 40, but we need it to add to negative 13. So to match up to the signs here, we're going to have to use negative 5 and negative 8. That will still multiply to positive 40, right? Negative and negative make that positive. But when I add these together, negative 5 plus negative 8, I will get the negative 13. So these are the two numbers I'm looking for in step 2. And then step 3 is jump to your answer, right? You just get to immediately factor this as v plus the first number, which is negative 5. So v plus negative 5 would just be v minus 5. And then v plus the second number, v plus negative 8, is just going to be v minus 8. Sorry, I keep pushing the button on my pen. That makes me erase. All right. And so that'll be the answer. And again, you could check by foiling that out. All right. Let's look at the next example. This one, what you want to do is rearrange it so that it's in the right order. So you want to go from highest to lowest power before you start trying to factor it. So I'm going to rewrite this problem, b squared, but then I'm going to put the minus 8b second and then the minus 20 last. So it's in standard form. So it's in order from highest to lowest power. Then we'll jump into step 1. C in this case is negative 20 and b is negative 8. So we need two numbers that multiply to negative 20 but add up to negative 8. The numbers that multiply to 20 are 1 times 20, 2 times 10, 3 doesn't work, 4 does, 4 times 5, and I think that's it. So none of these add up to 8, but we're not actually looking for numbers that will add to 8. We're looking for numbers that will subtract to give me 8, because I need c to be negative this time. And the only way that's possible is for one number to be positive and one number to be negative. And if you're going to add a positive number to a negative number, they actually subtract each other rather than add together. And so we actually want this pair of numbers here, 2 and 10. That multiplies to 20, and if I subtract those, I will get 8. But I want to make sure I set this up correctly, so I need to think about which one should be positive, which one should be negative. Because I want it to add up to a negative 8, I need the bigger number to be negative. So I need the 10 to be negative and the 2 to be positive. Negative 10 times 2 is negative 20, so it gives me the negative sign. Negative 10 plus 2 is negative 8. So this number fits the description that we are, how do I want to say that? These pair of numbers fit the description of the numbers that we're looking for. And so that's step 2. And then step 3 is, now you can go ahead and factor. It'll be b minus 10 times b plus 2. And that's how that one factors. All right, and that's, I keep forgetting to put it, but that's step 3. All right. So for this problem, first issue is it's not in the right order, so we want to reorder it from highest to lowest power. We'll put the w to the third power first. It's negative, that minus sign is going to follow that, so we're going to have negative w to the third power plus 3w squared plus 70w. All right. Now, the next issue is, now that you have it in the right order, is that this actually can't be factored the way we were just doing the last problem. It doesn't fit the right form. It has to look like this. X squared plus bx plus c, where x could be whatever variable they want to use. But it has to be squared, x squared, with a 1 in front of it, and then bx plus c. So the highest power for this process to work has to be 2. Here, the highest power is 3. So it doesn't quite match up to the formula that we need it to match up to for this process to work. But we can fix that because w is a common factor in all three of these terms. So the first thing we should always do on every factoring problem, I didn't mention it on the last few examples, but I should have, is factor out the common factor. So the common factor here is going to be w. So we'll factor out a w, and that's going to leave me with negative w squared plus 3w plus 70, which is closer to what I need to see. But now the issue is we don't have a 1 in front of the w squared. In order for this shortcut to work that we're using, this needs to be a 1. And we have a negative 1 here instead. But again, that's something I could fix, and maybe I should have fixed it from the beginning when I factored out the w, because I could also just factor out a negative with it. In fact, that's normally what I would have done, but I wanted to take the time to make this point, that you're not going to be able to do this shortcut with a negative sign in front of the w squared. So instead of just factoring out a w, we should factor out a negative w. And that's going to leave me with positive w squared minus 3w minus 70. Right? We talked about this in the last section, 4.3. When you factor out a negative, it changes the sign of what's left in the parentheses. So now we have a 1 in front of the w squared. And it matches up to this formula, so now we can factor it using that process we were just using. So the first step is to identify c and b. c is equal to negative 70. b is equal to negative 3. So we need to find two numbers that multiply to negative 70 and add to negative 3. And you can make your list over here, but I'm just going to go ahead and write the answer down. And so if you think about it for a minute, maybe you'll come up with the answer as well. It's going to be 10 and 7. 10 times 7 gives me 70. And if I subtract 10 and 7, I will get 3. And that's what I need the numbers to do, because in order to multiply to a negative, one will have to be negative, the other will have to be positive. And when I add two numbers like that, they actually subtract each other. Negative 10 plus 7 gives me negative 3. Negative 10 times 7 gives me negative 70. So these are the two numbers you're looking for. And now I can factor this using those two numbers. It'll factor as w minus 10, w plus 7, and then make sure you copy down the greatest common factor as well. And so this is what you'd want to type into Math Excel. All right. So make sure you write your expression in order from highest to lowest power, and make sure you factor out the greatest common factor before you get started using this process right here. All right. The last topic in this section is factoring quadratic-like expressions. The following examples can be factored using a similar process as the previous examples, even though they don't technically match the formula x squared plus bx plus c. We can either make them match, or the process just happens to work anyways, even though it doesn't quite match up. And that's the case for this first example here. So we have c squared plus 12cz plus 35z squared. So this really doesn't fit our formula of x squared plus bx plus c, because there's two variables in this problem instead of just one, right? So this, I'm trying to underline the c twice, this formula really only allows for one variable. Our problem, we have two variables. However, if your variables fit this format, if they fit this structure, you can factor it as if the second variable is not there. The structure is this. For the variable c, the first term has 2 powers of c, right? There's c squared. The middle term has 1 power of c. The last term has no powers of c. So again, c is not a common factor that we could factor out, unfortunately. So I guess I should mention that. The first thing I would look for here when I have two variables is, can I just factor one of them out? So it's just out of the picture. But we can't, because z is also not a common factor because it doesn't exist in the first term. So for z, the pattern is the first term has no powers of z, the middle term has one power of z, the last term has two powers of z. So as long as your two variables fit this structure, you can factor it, factor as c squared plus 12c plus 35. Factor it as if that second variable is not even in the problem. Get that answer, and then we will fix it to account for that second variable. All right. So let's go ahead and factor this. Step 1, identify c and b. C is 35, b is 12. They're both positive, so this is kind of the best case scenario. Find two numbers that multiply to 35 and add to 12. It's going to be 5 and 7. All right. 5 times 7 gives you 35. 5 plus 7 gives you 12. So now we can factor this. This is step 3. Factor it as c plus 5, c plus 7. All right. And so you factor it as if the second variable is not there. But then you have to go back and account for that second variable. And it's pretty easily done. All you have to do is add that variable to each of these numbers. Not add it, but write it with each of these numbers. So instead of just writing 5, I'm going to write 5z. And instead of just writing 7, I'm going to write 7z, which is why I left a little bit of space there when I was writing it down. And that will account for that second variable, put it exactly where it needs to go so that it gives you the right answer. So to account for this second variable of z, all you have to do is put that variable with the two numbers inside of your two factors. All right. So this problem's not too bad. You basically just ignore the second variable, factor it as usual, and then put that second variable in your answer with the two numbers that you have. And that gives you the correct answer. And you can check. You can check to make sure that actually fixes it, right? So we'll go ahead and FOIL. So let's just go ahead and check this one. We haven't checked any in a while. So we'll FOIL this out. We're going to take c plus 5z times c plus 7z, and we're going to FOIL. So we'll do first, c times c gives me c squared. We'll do the outer terms. C times 7z, I'm going to put the number first, so we'll have 7, and then alphabetical order, c and then z. All right. So when you multiply this to this, nothing really simplifies. You just have 7, z, and c, but you're going to put it in this order. You do the same thing with the inner terms. 5z times c, I'll put the 5 first, the c second, and then the z last, keeping it in alphabetical order. And then for the last terms, you'll have 5z times 7z, which is 35z squared. And when you combine these together, you get 12cz, right? They're like terms because they have the same variable part. And so you get 12cz. It's hard to say those two letters together. And everything else copies down, and it matches back up to our original problem. So by putting the z with those two numbers, magically fixes everything. I really don't like this trick because it's not a very mathematical trick. It's ignore that variable, factor it as usual, and then put the variable in your answer, and it just magically happens to fix everything. But that's the best method that we have at our disposal right now. All right. The last example I have here for you is this one. We have a to the 6th power plus 7a to the 3rd power plus 10. So this, again, doesn't fit our formula of x squared plus bx plus c, but we can make it fit this. It's pretty, it has some similarities. Let's just start by saying that, right? There's 3 terms. This is a trinomial. It's 3 terms. That's why it's called a trinomial. And this one has 3 terms, right? So that's one similarity. The last term is just a constant. It's just a number, right? C is just a number. It's just going to be 10 in this case. So that's another similarity. So maybe there's a way to, how do you want to say this? Manipulate it, fix it, rewrite it so that it matches this formula, right? And there is. So what we want to see here, instead of a to the 3rd power, what I would have liked to see is a variable to the 1st power. So what we're going to do is actually cover it up. And when I'm in class, I literally take a piece of paper and write this letter on top of it and cover up the a to the third power with this piece of paper. So it's like you're putting a mask over it. You're replacing the a to the third power with a new letter to make it look the way you want it to look. And what we want it to look like is this. Now we could use x in this case because the only letter you can't use is a, because you're already using a in the problem. You can't use a as your variable to cover it up. You can use any other letter you want. The standard choice is W. I don't know why, but W is a very common letter to use as a substitution variable. So we replace the a to the third power with the letter W. We're just going to cover it up. And so we'll still have the plus 10 as our last term. We'll still have the 7 in front of that. And what we would like to see here is a W to the second power. Right? Then it completely matches up to my formula, and I can factor it using the same methods that we've been using this whole section. But I can't just put the mask on it like that. Because I've already made a choice for what this mask is covering up, it has to cover up the same thing here. It has to be consistent with your first choice. So if W is taking place of a to the third power here, then that's the only thing W is allowed to take the place of. So is it okay for W squared to take the place of a to the sixth power based on this choice that we've made here? That's the question we have to ask ourselves. So what you want to do with this is rewrite it as something to the second power to see if the W can, to see if we can make this a W here. And the only thing we can make a W here is a to the third power because that's the choice we made earlier. And it turns out that is exactly what happens. We can rewrite a to the sixth power as a to the third power raised to the second power, right? Because those exponents would multiply. We talked about that back in section R.7 a few sections ago. This is the case where they multiply. 3 times 2 would give me 6. So I can rewrite a to the sixth power as a to the third power squared. And then this a to the third power can be replaced with a W again, just like we did over here. And then that power of 2 just gets copied down. All right, so W is covering up a to the third power in both cases. That's the important thing. It has to be consistent. So we get this new expression with W covering up this a to the third power, and it perfectly matches our formula. So now we can factor it using the same technique that we've been using this entire section. So C is equal to 10, B is equal to 7. We need two numbers that multiply to 10 and add to 7. That'll be 5 and 2, or 2 and 5. The order you put it in doesn't matter. Right? And so I can factor this as W plus 5 times W plus 2. And you might feel like, okay, I factored it. So I type that answer into Math Excel and I'm done with the problem. But Math Excel is going to tell you that you're wrong, that this is not the right answer. And if it could talk, or if it had a better response, it might say, what's W? What do you mean by W? Because Math Excel doesn't know what W is, right? Math Excel only knows the variable in this problem is A. It doesn't have any other information about the problem except, what the problem is, I guess, but it doesn't recognize W as a variable in this problem because it gave you the problem with A as the variable. So your answer needs to end with A as the variable, right? So once you're done with W, you need to take the mask back off. Underneath the W, what we're going to find is a to the third power, right? That's the thing it was covering up. And that gets us back to the original variable that we started the problem with. So take the W back out, put the a to the third power back in, and you get this answer. And this is what you need to type into Math Excel. All right, because Math Excel is not going to have any idea what you mean by W. That was something we introduced to the problem to help us work through it. But once we're done with it, once we've used the W the way we need it to, we take the W back out, put the A back in. Right? And underneath the W, we find a to the third power. All right, and again, this was step 3. I keep forgetting. Step 1, step 2, step 3. Okay, so this last page that I have are some problems for you to try out based on problems that we did earlier in this section. So pause the video and see if you're able to get the answers for these, work through each of them, and then resume the video to see if you came up with the right answer. I'm going to work through these pretty quickly here. So this one, we can just jump right into it. We need two numbers that multiply to negative 20 and add to positive 8. We saw this earlier in the video, except the signs were a little bit different. But it's going to be positive 10 and negative 2. So this will factor as W plus 10, W minus 2. So that's all there is to that one. For this one, you want to write it in order from highest to lowest power. So it'll be negative t squared plus t plus 30. Make sure when you move these terms around, you take the sign of those terms with them. This one we cannot factor using the same method as we have here, because there's not a 1 in front of the t squared, it's a negative 1. So before we can use this method, we have to factor out that negative. So I kind of misspoke. We can use this method, but we have to do something first. Factor out a negative sign. Even though there's no common factor here, we can't use this technique if there's a negative sign in front of the t squared. So let's factor the negative sign out. That's going to leave me with t squared minus t minus 30, right? Changes the sign of each of those terms inside the parentheses. And then we can now use this technique to factor this, right? So step 1, I'm not putting my steps very good here. This is step 2, this was step 3. Step 1, c is equal to negative 30, b is equal to negative 1. So we need two numbers that multiply to negative 30 and add to negative 1. It's going to be negative 6 and positive 5. Right? That multiplies to negative 30, adds to negative 1. So this will factor as t minus 6, t plus 5. Copy down the common factor, which is the negative sign, and that's what we would type into Math Excel. This one, the first thing you want to do is factor out the 4, because again, you can't use this process while there's still while there's a number in front of the y squared. I'm sorry, I feel like I'm spacing out a little bit. So we have to factor out the common factor of 4 to make this a 1 here, right? So we have to have a 1 in front of the y squared in order to use this technique. So factor out the 4. We get y squared minus 12y minus, what was this going to be, 420? It'll be 45. Right? Then we can use this method. Now that there's a 1 in front of the y squared, we have c equals negative 45, b equals negative 12. Two numbers that multiply to negative 45 and add to negative 12 would be negative 15 and positive 3. Right. So that multiplies to negative 45, that adds to negative 12. So this will factor as y minus 15, y plus 3. So that would be the answer you should get here. And for this one, we're going to use substitution. We're going to replace the a to the 4th power with a w. This can be written as a to the 4th power squared. So I can replace this a to the 4th power with a w as well. So we'll have w squared minus 10w plus 25. I'm not going to write out the steps, but this will factor as w minus 5 times w minus 5, right? Two numbers that multiply to positive 25 and add to negative 10. But once you factor it, you're done with the w. You want to put the original variable back into the answer. So we're going to take the w back out, put the a to the 4th power back in. So we get a to the 4th power minus 5 times a to the 4th power minus 5. And so that's the final answer that you should be getting for this one. All right, so that concludes the video on section 4.4, which is factoring expressions of the form x squared plus bx plus c.